All right, so we're diving into data prep today. And I know our audience is pretty familiar with relational databases already, but this deep dive is all about taking things up a notch for data mining, getting those powerful insights without getting lost in the weeds.
Yeah, and that's where data preparation really comes in, right? It's like setting the stage before a big performance. If you skip this step, well, your results might not be accurate. And that kind of defeats the purpose of data mining, wouldn't you say?
Absolutely. It's like building a house on a shaky foundation. It's just not going to end well.
Well, so let's start with the basics, data cleaning. What are some of the common tasks you find yourself tackling there?
One of the biggest headaches is dealing with inconsistent data. Imagine you're analyzing customer data and you've got entries like Chevy and Chevrolet for the same car brand.
Yeah.
The algorithm's going to treat those as separate entities, and that can really mess with your results.
Right. It's like trying to solve a puzzle with pieces from different sets.
Yeah.
You'll never get the full picture. So what about missing values? How do you approach those? That's another tricky one. Sometimes you can replace missing values with an average or use some more advanced prediction methods based on other data points. But sometimes, if there's just too much data missing, you might have to just remove those entries altogether.
So it's a judgment call based on each situation.
Yeah.
What about incorrect data? How do you even begin to identify those?
Well, sometimes it's obvious, like a car with a mileage of 1 million kilometers.
Right.
But often it requires setting up some rules to flag those outliers or using your domain expertise to spot those subtle errors. It's a bit of a detective game.
Fascinating. So we've talked about cleaning up the mess, but what about data transformation? Why is that so important for data mining?
Well, transformation takes things a step further. It's about converting that data into a format that your algorithms can actually understand. For example, let's say you have a variable for car color with values like red, blue, green. Algorithms don't work well with words.
You got to translate it into their language, something numerical.
Right.
How do you do that?
One way is using a technique called one-hot encoding. Basically, you assign a numerical code to each color. So red might become 001, blue becomes 010, and so on. This lets the algorithm work with the color information numerically.
That's clever. It's like giving each color its own unique fingerprint that the algorithm can recognize. What are some other common data transformation techniques?
Feature scaling is another really important one. Think about variables like car mileage, which can range from a few thousand to hundreds of thousands, and then car age, which might be just a few years. Those vastly different scales can confuse some algorithms.
It's like trying to compare apples and oranges. They're just not on the same level. So
Yeah.
How does feature scaling address this?
It brings all the variables onto a similar scale, typically between 0 and 1. This makes sure that no single variable is dominating the learning process, and your algorithm can learn from all the features effectively.
I see. So it's all about creating a level playing field for all the variables involved. Now, I'm curious about feature selection. It sounds like we're getting into the art of choosing the right ingredients for our data mining recipe.
That's a great analogy. Feature selection is all about picking the most relevant variables for your analysis. You might think more data always means better insights, but that's not always true. Sometimes too many variables can actually make things worse.
So sometimes less is more. Why is that?
Absolutely. Too many variables can introduce noise, make things overly complex, and even lead to something called overfitting, where your model performs great on your existing data, but fails miserably on new data.
It's like adding too many spices to a dish. You might end up masking the main flavors and creating something that's not very palatable. So how do you decide which variables are the VIPs, the ones that really matter?
There are a few different methods. Some use statistical measures to rank features based on their individual predictive power, kind of like a preliminary screening of your ingredients.
What are some other ways to go about this?
Well, there are methods where you use a specific machine learning algorithm to evaluate different sets of features, almost like doing a taste test to see which combination creates the most flavorful dish. And then there are methods where the feature selection happens automatically as part of the model training, like a chef who just instinctively knows which ingredients to use and in what quantities to create that perfectly balanced dish.
That sounds incredibly efficient. So it's about finding that balance. Not too many variables, but not too few either. You want those Goldilocks features, the ones that really contribute to the predictive power of your model. Now, all this talk about data cleaning and transformation makes me think of a real-world problem. The challenge of distributing cars to auction sites.
That's a perfect example. It really highlights how data preparation can have a real impact on those business decisions. Think about a car leasing company with thousands of cars coming off lease every month. They need to figure out which cars to send to which auction sites to maximize their profits.
And that's where data preparation comes in.
First they need to gather all the data they can on historical car sales. They make model, mileage, color, previous sale price, the location where it was sold, and the date of the sale. This data is like the raw ingredients for their prediction models.
So they're trying to use past sales data to predict future sale prices.
Yeah.
It's like studying market trends to make those smart investments.
Exactly. But before they can even start building those prediction models, they need to clean the data. That means dealing with any missing values, like information about the car's mileage or any damage it might have. They also need to standardize inconsistent data, make sure all those entries for Chevrolet are consistent and not mixed with Chevy. And of course, they need to identify and correct any incorrect data points.
So having a clean and consistent data set is like step one before even thinking about those models. It's like making sure your kitchen is spotless before you start cooking.
Absolutely. Once the data is all clean, they can start transforming it into a format that's suitable for analysis. For example, converting those categorical variables like car color into numerical values, maybe using that one-hot encoding we talked about earlier. They might also create new features based on the existing ones, like calculating the average mileage per year.
So it's all about manipulating the data to make it easier for the algorithms to process. It's like prepping those ingredients, chopping vegetables, marinating the meat, preheating the oven, all those essential steps to get ready for cooking.
Exactly. And then comes feature selection. They need to figure out which features actually drive those sale prices. Things like the car's make, model, mileage, age damage level, the auction location, even things like seasonality.
So they're trying to pinpoint those key factors, those ingredients that really influence car prices, the ones that will help them predict future sale prices accurately. It's like choosing the right spices to create the most delicious and aromatic curry.
Exactly. By going through those steps, cleaning, transforming, and selecting the right features, they're setting themselves up for success. They can build models to predict sale prices at different auction sites. Even consider things like the volume effect, how sending too many similar cars to one auction might actually lower their prices.
That's where optimization comes into play, right? Finding the best way to distribute those cars to maximize profits while considering things like transportation costs, auction fees, and inventory management.
Precisely, they can use optimization techniques to figure out the ideal number of cars for each auction site, keep those transportation costs down and sale prices high. And all of this is built on that foundation of well-prepared data.
This is fascinating stuff. It's like solving a giant jigsaw puzzle, where each piece represents a car and the puzzle board represents all those auction sites across the country.
It is a complex problem, but that's where the power of data preparation really shines. By taking the time to prepare that data properly, they can transform this seemingly impossible challenge into a solvable problem, leading to more efficient and profitable decisions.
This has been a great overview of data preparation techniques. We've explored why it's so important, some of the common challenges, and how it can be applied to a real-world problem like car distribution. But I'm curious about something else. What about adaptability? The car market is constantly changing new models, shifting preferences, economic fluctuations. How do you make sure your data preparation processes stay relevant?
That's a great question, and it brings us to the importance of adaptability. Real-world scenarios are always changing, so a truly robust system needs to be able to evolve with those changes.
So it's not a set it and forget it kind of thing. You need to constantly monitor and adjust your data preparation strategies.
Exactly. You need to regularly update your data sets with new information, retrain your prediction models, and refine those optimization algorithms to reflect the latest market trends. This ensures your decisions are aligned with the ever-changing reality.
That makes perfect sense. It's like recalibrating your compass to make sure you're still heading in the right direction now. Before we wrap up this section, I want to leave our listeners with something to ponder. We talked about the car leasing company and their challenge of distributing those cars, considering things like transportation costs, auction fees, and inventory management.
They also had to factor in those real-world constraints, things like weather delays, transportation disruptions, and even those sudden changes in demand at certain auction sites.
Right. And how do you think these real-world constraints could be incorporated into that data preparation process? That's something for you to think about.
It's a crucial aspect of building truly robust and adaptable systems that can navigate the complexities of the real world.
This has been a really insightful dive into data preparation techniques. We've covered why it's important, explored various cleaning, transformation, and feature selection methods, and even applied these concepts to a real-world challenge. And we've highlighted the importance of adaptability. But there's so much more to uncover, so stay tuned for part 2 of this data preparation deep dive.
Don't forget to like, share, and subscribe to The Deep Dive. For more exciting data explorations, we'll be back soon with more fascinating data topics.
Until then, keep exploring, keep learning, and keep diving deep into the world of data.
Welcome back to the deep dive. Before the break, we were talking about the importance of adaptability in data preparation, using that example of a car leasing company and how they need to constantly tweak their strategies to keep up with the ever-changing market.
Right, they can't just rely on a static model.
Yeah.
But let's zoom in a bit. We've been talking about data preparation as a whole, but I want to dig a little deeper into one specific aspect, feature selection. We touched on it briefly before, but I think it deserves a bit more attention.
Oh, absolutely. Feature selection is a critical step in data preparation, and it's often where the art and science of data mining really come together. It's about finding that sweet spot, having enough information to make those accurate predictions, but avoiding the pitfalls of having too much data.
Right. We don't want to end up with that overfitting problem where our model is a rock star with existing data, but completely falls apart when it encounters something new. So how do we go about picking the right features? What are some of the techniques involved?
Well, there are various methods, each with its own strengths and weaknesses. One common category is filter methods. These methods rely on statistical measures to rank features based on their individual predictive power. It's like doing a preliminary screening of your ingredients based on their properties, things like aroma, texture, or color. You're looking for the ones that seem most promising.
So it's a way of narrowing down the options before you start experimenting with different combinations.
Yeah.
What are some of those statistical measures used in filter methods?
Common ones include correlation, which measures the linear relationship between two variables, and information gain, which assesses how much information a particular feature provides about the target variable. The idea is to select features that are highly correlated with the target variable, but not too correlated with each other.
I see. So you want features that provide unique information about the target variable without being redundant. What are some other approaches to feature selection?
Another popular category is wrapper methods. These methods use a specific machine learning algorithm to evaluate different subsets of features, essentially wrapping the feature selection process around the model training. It's like trying different combinations of spices in a dish to see which blend creates the most delicious outcome.
That sounds more like a trial and error approach.
Yeah.
With the systematic approach, how do wrapper methods actually work in practice?
Well, you start with a set of features and a machine learning algorithm, and then you evaluate the performance of the algorithm using different subsets of those features, iteratively adding or removing features to find the combination that gives you the best results. It's a bit more computationally expensive than filter methods, but it can lead to more refined feature selection.
So it's a trade-off between computational cost and potential accuracy. Are there any other techniques commonly used for feature selection?
Yes. There are also embedded methods. These methods incorporate feature selection as part of the model training process itself. So instead of having feature selection as a separate step, these methods automatically select relevant features during training, optimizing both feature selection and model performance simultaneously.
That sounds incredibly efficient. It's like having a chef who just instinctively knows which ingredients to use and in what quantities to create a perfectly balanced dish.
Yeah.
How do these embedded methods achieve this simultaneous optimization?
They often use regularization techniques, which basically penalize models for using too many features. This encourages the model to focus on the most relevant features while minimizing complexity and overfitting.
It's like adding a constraint to the recipe, forcing the chef to be more selective with their ingredients. We have filter methods, wrapper methods, and embedded methods, a whole toolkit for feature selection. But with all these options, how do you choose the right approach for a particular problem?
That's the million-dollar question. The best choice often depends on the specific data set, the data mining task at hand, and the computational resources you have available. Sometimes a simple filter method might be enough, while other times a more sophisticated wrapper or embedded method might be needed to get those optimal results.
It's like choosing the right tool for the job. You wouldn't use a hammer to screw in a screw, right?
Exactly. It's about understanding the strengths and limitations of each technique and picking the one that best fits your needs and constraints. And remember, feature selection isn't a one-time thing. It's often an iterative process. You experiment with different techniques and refine your feature set as you learn more about the data and the problem you're trying to solve.
That makes sense. It's all about being flexible and adapting to the insights you gather along the way. Now, I want to shift gears a bit and talk about something that's been on my mind. We've discussed how data preparation can help a car leasing company, optimize their car distribution strategy. But what about other industries? How can data preparation be used to tackle problems in different sectors?
That's a great question. The beauty of data preparation is that it's a fundamental concept that can be applied across so many different industries. Let's take healthcare, for example.
Okay, so how would data preparation play a role in healthcare?
Imagine a hospital trying to predict patient readmissions. They could gather data on past patients, things like their medical history and demographics, length of stay, and the medications they were prescribed.
So they're essentially trying to identify those patterns that might indicate a higher risk of readmission, right?
Exactly, but before they can build that predictive model, they need to go through the same data preparation process we've been talking about. They need to clean the data, handle missing values, maybe transform some of the variables, and select the most relevant features for their model, for instance. They might convert categorical variables like diagnosis codes into numerical values using that one-hot encoding we talked about earlier, or they might create new features based on combinations of existing variables, like a feature that represents the number of chronic conditions a patient has.
So they're creating a more refined and informative data set that can be used to train a model that can accurately predict those patient readmissions.
Precisely. And by identifying patients who are at a higher risk of readmission, the hospital can intervene early, potentially preventing those readmissions from happening and ultimately improving patient outcomes.
That's a powerful example of how data preparation can be used to solve those real-world problems and make a real difference. It's not just about optimizing profits, it's about improving people's lives.
Absolutely. And this is just one example. You can apply these same principles to countless other industries: finance, manufacturing, retail, entertainment. The possibilities are pretty much endless.
This is really fascinating stuff. It's
Yeah.
amazing to see how these seemingly technical concepts can be applied to solve such a wide range of problems and make a real difference in the world.
It's all about using data to understand the world around us better and to make those smarter decisions, and data preparation is the foundation upon which all of that is built.
I'm eager to hear more about those real-world applications, but I think we'll save that for part 3 of this data preparation deep dive. We'll explore how these techniques are being used in various industries and delve a little deeper into the ethical considerations surrounding data preparation.
Don't miss it. And remember, if you're enjoying this deep dive into data preparation, be sure to like, share, and subscribe to the deep dive for more insightful data explorations.
Until then, keep exploring, keep learning, and keep diving deep into the world of data. Welcome back to the deep dive. We've been exploring the world of data preparation, from cleaning and transforming data to that crucial step of feature selection. And before the break, we talked about how these techniques can be applied across different industries, even in healthcare, for things like predicting patient readmissions.
Yeah, it's amazing how data preparation can be used to solve such a diverse range of problems. It really highlights how data-driven decision-making is transforming so many different sectors.
Absolutely. And speaking of different sectors, I'm curious to hear more about those real-world applications of data preparation. What other examples come to mind?
Well, let's think about the financial industry for a second.
Yeah.
Data preparation plays a huge role in things like fraud detection. Imagine a bank trying to identify fraudulent transactions. They might collect data on past transactions, things like the amount of day location and the type of purchase.
So they're looking for those patterns that deviate from the norm, right? Those red flags that could indicate fraudulent activity.
Exactly. But before they can even train a fraud detection model, they need to prep that data. This might involve cleaning the data to handle missing values or incorrect entries, maybe transforming those categorical variables like merchant categories into numerical values using one-hot encoding. And they might even create new features like the frequency of transactions within a specific time frame or the average transaction amount for a certain customer.
So they're essentially creating a more refined data set that captures the nuances of transaction behavior, making it easier for the algorithm to spot those subtle anomalies that might point to fraud.
Precisely. And by accurately identifying those fraudulent transactions, the bank can prevent financial losses for both themselves and their customers.
That's a great example of how data preparation can have a direct impact on a company's bottom line and protect their customers. What about other industries? Any interesting applications there?
Let's take the retail industry, for example. Data preparation is essential for things like personalized product recommendations. Imagine an online retailer wants to suggest products to customers based on their browsing history and past purchases. They might collect data on which products customers have viewed, added to their carts, or actually purchased.
So they're trying to understand each customer's unique preferences and then tailor their recommendations accordingly. It's like having a virtual shopping assistant that knows your taste better than you do.
Exactly, but before they can build that recommendation system, they need to prepare that data. They might need to handle missing values if a customer hasn't bought anything in a certain category, or they might need to transform those categorical variables like product categories into numerical values, and they could even create new features that represent combinations of products that are frequently purchased together.
So it's all about crafting a data set that captures those intricate details of customer behavior, allowing the algorithm to generate those spot-on recommendations.
Yeah, by preparing the data effectively, they can boost the accuracy of their recommendations, which can lead to increased sales and happier customers.
This is really eye-opening. It seems like data preparation is kind of like the unsung hero behind so many data-driven solutions we see every day.
It really is. It's the foundation for all those fancy algorithms and models. Without proper data preparation, even the most powerful algorithms can give you misleading or just plain wrong results.
It's like building a skyscraper on a shaky foundation, no matter how impressive the design. It's not going to last without that solid base. And that's why data preparation deserves so much attention and care.
Absolutely. It's a crucial step that should never be overlooked.
This has been a fascinating journey into the world of data preparation techniques. We've talked about why it's so important. We've explored those different cleaning, transformation, and feature selection methods. And we've even seen how these concepts can be applied to real-world problems across industries.
We've seen how data preparation can help companies make smarter decisions, create better experiences for their customers, and even improve healthcare outcomes. It's a fundamental concept that really underpins the success of any data-driven initiative.
So if you're ready to unlock the true power of your data, remember that data preparation is the key. Master those techniques, and you'll be well on your way to making informed, data-driven decisions that can truly transform your business and the world around you.
And if you're eager to continue your data journey, don't forget to like, share, and subscribe to The Deep Dive for more insightful data explorations.
Until next time, keep exploring, keep learning, and keep diving deep into the world of data.